Hello, my name is Kaylee Hartman, and today we are going to learn how to find the roots of functions through iteration. What is an iteration? Well, an iteration is the repeated application of a function or process in which the output of each step is used as the input for the following iteration. Essentially, it's a method to solve equations by finding an approximate solution. Now, there are many different types of iteration methods, each with varying accuracy and precision. The elementary numerical analysis textbook gives 4 iteration methods, but we're just going to examine iterations 2, 3, and 4. Before we look at how to solve each method, let's understand how the process works through an example. Starting with the equation x squared plus 5x equals 10, we'll choose an initial guess of 3. After you solve for x, you can insert that into your chosen iteration formula and solve. In this case, I'm using I4, which I will show more in depth later. Examine if this answer is the same as the previous to the 6th decimal place. In this case, it is not. Therefore, we're going to repeat the process and take the output that we got and use that answer for the input and the value of x. We will repeat this process until we see that x4 and x5 have the same answer to the 6th decimal place. Then we can determine that this is an approximate solution. All right, great. Now that we know how the process works, we can jump into computing these 3 types of iterations. We'll start with the question x squared equals 13. You can totally do this process by hand, but here I'm going to show you a quicker method by using the online platform GeoGebra. And make sure you're using GeoGebra Classic to get the spreadsheet feature. Also, by using a table, it makes it easier to compare the various iteration methods. Before I make my table, I'm going to use the graph function to get an idea of where the root is. In the case that there are multiple roots, it becomes important that you choose an initial guess near your desired root, so that it converges to the root you're trying to find. If you'd rather not graph it, you can use your knowledge in trying to find the square root of 13, that the square root of 9 is 3, and the square root of 16 is 4. So the square root of 13 must be somewhere between those. From the knowledge we have, we can choose 4 as our initial guess. Starting with iteration 2, which the formula states xn plus 1 equals a over xn, we will substitute our values here. So in our table, we will say that it equals 13 over xn, which is 4. We can simply drag this down to reveal the next 3 iterations for this method. Or if you're solving by hand, you can continue plugging in your output as your input. It appears in this case that the numbers are oscillating between 4 and 3.25, but did not converge to a root. So let's check out iteration 3. The formula here is xn plus 1 equals 1 plus xn minus xn the whole squared over a. Just as we did with I2, we will plug in our values for xn and a here. To find that x1 equals 3.769. And again, we will drag this down to get the next 3 iterations. For I4, it has us add the value of xn to a, divided by xn, and then have that whole value. Plugging this in and dragging down, we can see the convergence happening much quicker than in the previous case. But which is the most accurate? We can figure this out by calculating the error between these approximation methods and the actual square root of 13. It is possible to notice that I2 does not converge, so the error here is not needed. But for I3, we will take the exact value of the square root of 13 and subtract iteration x4 from that value. We do end up with a small error. But when looking at I4, we find that this has the same decimal count as the exact value to the 10th decimal place. There is no error all the way to the 10th decimal. If we take a closer look at how iteration 4 is working, we can say that it is actually a simplified version of Newton's method, which you may have learned in Calculus 1. Since we're taking the tangent line at xn, we can use this formula based on the general formula y minus y1 equals the slope multiplied by x minus x1. We want to find the x-intercept, so we set y equal to 0 and solve for x. If we simplify and make the equation applicable to any n, we get Newton's method. We can take the values from our last example, f of x equals x squared minus 13, and plug those into Newton's method, where you have your value xn minus your f of x over the derivative of f of x, which is just 2x here. You'll get the equation we were working with, I4. Here's a visual representation of what is taking place during this process, as you choose the value x0, taking its tangent, and use the place where that tangent crosses the x-axis as your new input. This process repeats as it grows closer and closer to the actual value of x. It is possible, if you have a TI calculator, to make yourself a program, and I like to use Newton's method because it's just the most accurate and quicker than the other methods I showed. So if you just go to your program and go to New, then you'll insert the program name, which here we'll say is Newton's, then enter. On your calculator, press Program, scroll to I/O, and the third one down will say Display. Insert Display, and then in quotations, you can type the word guess. Enter. Again, pressing Program, going to I/O, this time pressing the first one, which is Input, then X. Again, enter. Pressing Program, scrolling all the way down to 9 and labeling that as 1. Enter. Here is where we're going to type in the actual equation, which will start with x, which was our initial guess, minus parentheses y1, which you can find in vars, then scrolling to y-vars and inserting y1. This way you don't have to type the function every time, as long as you have the function inserted into your y1. Then divide that by the derivative of your function, which you'll find if you press math, then 8, and in parentheses you'll have y1 again, which is in vars, y-vars, comma, x, and you're going to store this as n, which store is at the bottom left of your calculator, and then enter. Again, you'll press Program, scroll to I/O, and go down to the third option, which is Display. Then you'll display that as N. Again, Program 8, which is pause, enter. Then you're going to put in the absolute value of n minus t, which can be found under math. And then you're going to store that whole value as t and enter. Next, you'll have n storing as x, enter, program, finding if t is greater than 0.000001, enter, and then your last step is going to be program. Scroll down to go to insert 1, and there you have it. Your program is complete. I hope that this video is helpful, and good luck.